So all of these changes within the x values are consistent. 1 plus 1 is 2. So let's look at the y values. So -8, from -8 to a -1, what's happening? Well, we are adding 7. We're adding 7. -8 plus 7 gives us a -1. What's happening from -1 to 0? Well, in this case, all we're going is -1, and we're adding 1 to it to get 0. Well, those aren't the same. Let's look at from 0 to 1. Well, when we're at 0, we add 1 to get 1. And then what happens from 1 to 8? Well, we're at 1, we add 7 to get 8. Well, we can clearly see here that the y values are not consistent. They are not constant. So that means that this is this is not data for a linear equation. Okay, so even though, so we can say the equation y equals x cubed is not a linear equation. Because even though x increases by 1, y increases by a different amount each time. Okay, so this is not a linear equation. However, we still need to go ahead and graph it. So we know just by our Math Street Smarts that a cubic function is going to look something like this. But let's go ahead and graph the points, which are solutions to this cubic function. But we're just going to go ahead and see what it looks like. So the first point is -2, -8. So here we go, -1, -2, -8. 1, 2, 3, 4, 5, 6, 7, 8. It would be right there. Then the next one is -1, -1. So -1, -1 is right here. Then we go through the origin, which is 0, 0, and then 1, 1, 1, 1, and then lastly 2, 8, which would be 1, 2, and then up 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So what that means is that our graph looks something like this. And that is the cubic function. All right. Okay, on to the next example. So this one is a little bit different. Example 1C, it says graph the equation and tell whether it is linear. Now these are one of my favorite ones to do a little, a t-table for. So we're gonna do a t-table here. And we're gonna, and it's called a t-table because it makes a t. So we're gonna have x values and y values. Now this says that y equals 2. Well, we're gonna put in some values for x. We're just gonna -1, -2, -1, 0, 1, and 2, okay? If you notice, there is no x here, okay? What that means is that y is always 2. It doesn't matter what the x is, y is always equal to 2. So this is fun. If x is -2, what is y? Well, y is equal to 2. Okay, if x is equal to -1, what is y? Y is equal to 2. If x is equal to 0, then what is y? Well, y is equal to 2. If x is equal to 1, then what's y? Well, y is equal to 2. And if x is equal to 2, what is y? Well, y is equal to 2. So there you go. That's a table. That's how you could graph it. Now let's go ahead and graph this and see what kind of picture we get. -2, x is -2. Remember, these are all ordered pairs here. So all of these are ordered pairs. Anytime you have a t-table, these are all solutions to this equation, and they are also ordered pairs. So we have a bunch. And notice every time y is equal to 2, because that's what this graph is. So let's graph it visually. So we have -2, 2, so -2, 2. Okay, then we're going to go -1, 2, and then 0, 2, and then 1, 2, and lastly 2, 2. And really, any of these x values, if we were here, y would equal 2. 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 If we were over here at this a negative x value, y would equal 2. And this -1, y would equal 2. Y is always equal to 2. And so when you connect all of these, what you have is a horizontal line. It is a horizontal line, and yes, it is linear. Yes. Y equals 2 is a horizontal linear equation. That one's kind of fun. I like that one. Okay, very good. Now it is to that time. I want you guys to go ahead and check it out with this example. Now make sure we're going to do this equation. You need to make your vertical table. Go ahead and fill this in and then plot those solutions or those ordered pairs on here and figure out. You're going to graph the equation and tell whether it is linear or not. So it is time for our friend, the pause dragon, to come flying through. To remind you to pause and come back after you're done to see if you did it right. Okay, see you in a bit. Good luck. Bye. All right, we are back. I'm going to go ahead and make a table, a vertical table. So I have my x. You guys should have all made a vertical table. It's lovely fun. We're going to put our 2x plus 1 here. Give me a little bit of space to work. And then that's what's going, 2x plus 1 is going to equal y. And then we can make our ordered pair, which is xy. Okay, the values for x are going to be -4, -2, 0, 2, and 4. And before we do any type of calculations, let's just go ahead and use our math street smarts. Is this linear? Yes or no? Let's see here. Regular y, yes, it has a hidden 1. Regular x, yes, it has a hidden 1. So yes, this is a linear equation. So linear equation, yes it is. All right, so, but we can't just stop there. We got to show all our work. So let's go ahead and stick -4 in for x. Now remember, this is a negative number. Whenever you put a negative number in for a variable, you need to put it in parentheses. So we have 2 times -4, which is -8, plus 1, which is -7. All right, so our first point is -4, -7. All right. Our next one, we're sticking 2 in for x to figure out what y is. And we get 2 times -2, which is -4, plus 1, which is -3. So we end up with our x is -2 and our y is -3. 0 is always my favorite, because 0 times 2 is 0, plus 1 is just 1. So we end up with 0, 1. And then there was 2. We're going to plug in the x value of 2 to figure out what the y is. So we're going to go 2 times 2 plus 1, which is 4 plus 1, which is 5. So this point is a 2, 5. Lastly, there's 4. We're going to go 2 times 4 plus 1. 2 times 4 is 8 plus 1, which is 9. So we're left with 4, 9. Okay, I'm going to go ahead and transpose these ordered pairs into this horizontal table. So x is -4 and y is -7. X is -2 and y is -3. We have 0 and 1, we have 2 and 5, we have 4 and 9. All right, now we're going to look at the constant change of the x. What is going on? How are these x values changing? So from -4 to -2, that has a change of a +2. -4 plus 2 is -2. The difference between -2 and 0 is also a +2. -2 plus 2 is 0. How about from 0 to 2? 0 plus 2 is 2. And lastly, 2 plus 2 is 4. So we have a constant change here. What about this one? -4 plus what is -7? Well, yeah, it's adding. You're adding something to it. So I think it is actually, you're adding 4. -7 plus 4 is -3. What about what's the difference between -3 to 1? We are at -3. How do we get to 1? Well, looks like they go -3 plus 4, and that's equal to 1. Then we're at 1 and 5. What's the difference? Well, we're going 1 plus 4 and getting 5. And then lastly, from 5 to 9, we're going 5 plus 4 to get to 9. And yes, the y has a constant change as well. So we know that since the constant change is the same for the x and the constant change is the same for the y, we know that this is a linear equation, even though our Math Street Smarts already told us so. So we can say, yes, y equals 2x plus 1 is a linear equation because each time x increases by 1, by 2, I'm sorry, each time x is increasing by 2. Each time x is increasing by 2, y increases by 4. All right, we're almost done. Let's go ahead and figure out what this lovely picture of this linear equation looks like. To do that, we're just going to go ahead and graph these points. So we have -4, -7. So -1, -2, -3, -4, and then down 7. 1, 2, 3, 4, 5, 6, 7. Right there, I think. I kind of just lost it. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Very good. And then -2, -3 would be -2, -3, 1, 2, 3. Right here. And then 0, 1 would be right here. Right here. Did I mess up? -4, 1, 2, 3, 4, down 7. 1, 3, 4, 5, 6, 7. I did that right. And then -2, 3, -2, 1, 2, down 3, 1, 2, 3. And then this one is 0, 1. So, 0. It's a +1, not a -1. I'm sorry. I knew something wasn't right. Okay, don't ignore that one right there. That one's wrong. This is 0, 1. You guys are probably all watching going, oh, Mrs. Best, you're totally messing up right now. And you are right. I did mess up. Okay, so the next one is 2, 5, which should be here. 1, 2, and then up 5. 1, 2, 3, 4, 5. And then the last one is 4, 9. 1, 2, 3, 4, and then a +9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we go ahead and graph it, we would get this. And this is just a really good example. If you did something silly like I did, and instead of going 0 with a +1, I did 0, -1. And you can see how that point is not on the line. So you're kind of looking at this saying, hey, what's going on? I kind of did something wrong here. Because all of the solutions should be exactly on this line. So anytime you have some type of point that's off, you want to make sure you kind of relook at that, relook at the math, and make sure you just didn't make some silly error. All right, we will see you next time. If you did this right, great job. There's a lot going on.